with measures of central tendency, we're talking about the center. Okay, we're talking about the center. We have our most common, you've already heard, you already know what mean is. Mean is just an average. And basically you take all of the data entries, add them up and divide by the total number of data entries. We have two types of means. The first one is population mean, and the second one is the sample mean. Notice both are computed in the same manner. You simply add up everything, divide by the total number of data entries. The important information, you need to recognize that mu, that's mu, is the population mean. And then this guy is X bar. X bar represents the sample mean. Okay, so that's just a notation-wise issue. The median is just what it says. It is in the middle. The median is in the middle. So you need to arrange your data in order, preferably from smallest to largest. Preferably from smallest to largest, and then locate the middle of that data set. If there is an even number of data entries, you're going to average the two middle data entries. Okay, so average, add them up, divide by 2. Okay, so that's the median. The mode is the entry that occurs the most. So MO, mode, most, MO. Median, think about what is the center of the freeway, where the grassy area is. That's the median, which is located where? In the middle. And then mean is your average. A data set can have one mode, more than one, or no mode. Okay. Next, please. Here's your example. It says the maximum number of seats in a sample of 13 SUVs is listed below. Find the mean, median, and mode of the data set. Which is the best or which is the worst central tendency. Okay, so first question, mean. All you need to do is add them up. This is a sample, so notation wise is going to be X bar. It's going to be the sum of the X values divided by the total. We know that the total is 13. So you're adding up all of these entries. Let me know what you get when you add up all of the data points.
97.
Okay, confirm 97. Randall, you have them added?
I'm working.
Okay, we got a 97 and a 95 on the table.
I got 95.
95 twice? Okay, so we got 2 that's confirmed 95. So we're gonna go with it. Okay, we have 13 data entries. So 95 divided by 13. Okay, how much? 7.31. 7.31. And of course, my labs is gonna tell you how many places. Okay, questions on mean? Median. Median, they have to be arranged in order. Okay. So smallest number is, we got how many? 1, 2, 3 sixes. How many sevens?
That's a sign of the devil.
2, 3, 4, 5 sevens, 3 eights, and 2 nines. Okay. So you have it in order. What's in the middle? 7? I think it's this one. Or maybe it's that one. It's the third 7. Third 7. All right, so my median is 7. The median is 7. Mode.
7.
Okay, mode, the value that occurs the most is 7. All right, discussion. Which is the best or worst measure of central tendency? Notice all of them pretty much gave us the same. Okay. Which one would be the best? Or which one would be the worst?
In this case, I feel like most was the best because it was looking at it in its original form. I could have guessed 7 straight away.
Okay. So in this situation, mode is probably the best. Okay. Which one would be the worst?
I guess I feel like the most time consuming and therefore maybe the worst in that sense is the median because you have to take time to organize your numbers. And, right.
Right.
Unless you
Okay.
doing it by hand.
Doing it by hand. So your rationale for median being the worst is the time it takes to.
So that's
Come up
not.
here. What do you do?
So you're talking about accuracy.
Okay, so question. Same data set. Let me see if that's on my next page. No, it's not. Same data set, all right? What if I added a, kind of a bad example. It says an SUV, we can have a van. Let's add a 15 out there.
Okay.
Add a 15 to your data set and add a 2.
So then our median still stays the same, most still stays the same, the only thing that changes is the mean.
Okay. So how does that, so you, on 95, you're gonna add 15 and 2. Okay, so new X bar, you said 112 and divided by 15?
Oh, right, I did mess that up.
Okay, so it's still 7.466. Okay. Is the mode still the same?
Yes.
What about the median?
Same.
It's still the same. What changed?
You added 2.
We just added 2.
Okay, so add 50 to that data set. You want somewhere with it. Okay, so now we got 162 divided by 16, and that gives us how much? 125. Does my median stay the same?
Because now it's even, so then we have to add the 2 middle numbers.
Mhm.
And divide them
By
by
2.
2. So yes.
It will be the same. Median is the same. And what else?
The mode is also
The mode is also
the same.
the same. So are you still saying that the median is the worst? It's saying the same. The median is actually the best measure of central tendency. Why? Because it's not affected by outliers. Notice when we had those extreme values of 50, that shifted my mean.
Right.
Okay, so technically we shouldn't be using mean. Right. So the best is the mean, the best is the median. The best measure of central tendency is actually the median, because that's going to give you a true middle. Okay. Your mode will come in second because it's just most. It's not necessary. We could have had 3 2s out there, and 2 is not a measure of central tendency. I mean, 2 is not the middle. That's what I'm trying to say. And then the mean, of course, is affected by outliers. Okay, so FYI. So each central tendency has its advantage. An outlier is a data entry. Randa, you okay? That each an outlier is a data entry that is out of place. So here's your sample. You got 3, 6, 4, 3, 1, 6, and then 77. Obviously, 77 is an outlier. Okay, so that's going to skew your mean. I just answered the right. Mm-hmm. Right. Okay, so you have that information. The mean is influenced by outliers. The median is not affected by outliers, and it usually falls in the middle. And the mode is not influenced by outliers. It's just a one-time occurrence. We okay here? That was 3.1. We had 3.2. Variation in shape. Make sure I'm still recording. Okay. Variation in shape is 3.2. So we've already talked about range in chapter 2, I think. Range, we took the maximum minus the minimum. We took the maximum minus the minimum. A deviation of a data entry is the difference between the data entry and the mean. So it is, your data entry is X minus mu. Mu is a population mean. What I've done here, I've already completed the table. We got to finish it up and find the variance and then the standard deviation. Okay, so the salaries in thousands of dollars of a company's 3 employees. We are using mu because this is a population. The company only has 3 employees. To find the deviations, we got to find the mean first. I computed the mean to be 40.667. How do we compute the mean? The sum of x mu is equal to the sum of x divided by n, where n is equal to 3. And I don't know what that sum is. $117. I'm off by 5.
35, 40, 47.
122. I was off by 5. All right. So 122 divided by 3 should give us that 40.667. All right. So your deviations, your data entry minus your mean. Okay. If I were to add the deviations together, that'll give me a nice little 0. That means nothing to us. The deviation, when you take your mean, your data entry minus your mean, and add all of those deviations up, it's gonna give you 0 every single time, okay? Which means nothing. So that brings us to the variance and the standard deviation. All of these are measures of variation. So the variance says you're gonna take the deviations that we just computed and square them and add them together. It's the sum of the deviations. So the deviations that we had were negative 5.667, all of these here. Square them and add them up. Square each one and then add. In other words, negative 5.667 squared plus negative 0.667 squared plus 6.333 squared. Divided by 3. Let me know what you get there. What did you get for my numerator? Uh-huh. So far? Okay. Uh-oh. What time is it? 6:30? We got a student that's outside.
Oh, are they still there?
Yes.
Okay. 72.67.
Okay.
Got the new card. I didn't get it on either. It wouldn't. But yeah. Put them all on.
Let me pause. Okay. All right. So did we come up with a consensus on the numerator of this little? Okay. 72.67. And we're dividing that by what? 3? And that's going to give me about 24.22. All right.
Do we use, or am I seeing it from myself? Do you like the square root of anything?
Not yet.
You did have
When we do the standard deviation,
Oh.
we take square root.
Right there in front of us. Got it.
Mhm. Right. So we're doing this by hand. Yeah, we're doing this by hand. We're going to get the variance first every single time. And then to find the standard deviation, you take the square root. Okay. So we have our population variance as being 24.22. Our standard deviation, we're going to take and I can't do the little sigma thing. That's the notation, sigma.
It looks beautiful.
It's gonna be the square root of the 24.22. Okay? The square root.
Oh, so you just get that little sigma freaky thing by itself, so,
Mm,
okay.
yes,
So you can get to that. I'm tracking, I'm just making it harder.
okay. So this was my variance, right? To get sigma by itself, you take the square root of both sides. So that sigma means population standard deviation. So when you did that, you said you got how much?
I just did 27.2, right, but it's 4.92.
4.92?
Yeah.
Okay. So what does that mean? It says, what are we talking about? The average salaries? The average salaries differ by about 4.92 thousands of dollars. That's what it says. Or that's the interpretation. The average salary. Differs by 4.92 thousand. All right. That was what, page 4? So we did all of the computations already, which was on page 5. So I had you all do the work, and then I showed you the answers here to verify. Okay. So what is the standard deviation? Yeah, I'll see that. These notes are actually on Canvas. Okay. So the standard deviation measures the typical amount an entry deviates from the mean. It has the same unit of measure as your original data set. So remember, our data set was in dollars. So my standard deviation is also in dollars. It's always greater than or equal to 0. When sigma is equal to 0, that means the data set has no variation at all, or all of the data entries are the same. And the further away from the mean, sorry guys, that's muted. Now I won't be able to. That's why I said the phone was going off. I was like, is that my phone? Yeah. You would have been out there. All right. The further away from the mean, the more spread out it is. Okay. The data set. We did all of that. We did all of that. Blam, blam, blam. Sample, standard deviation. In sample variance, we use S. S squared is for sample variance. S is sample standard deviation. All right. The difference for sample is n minus 1 at the denominator. That's the only difference. Oh, you forgot to subtract 1. Gotcha. All right, we good here? Yes.
All right, and it's not to this specifically. I'm pretty sure that I'm like on top of my homework. It's just working ahead. Okay.
Yeah, I read that.
Well, it's like you said you've been like, oh, you started the answer. I'm like, wait, no, I just didn't finish. I just didn't.
No, I have some that are working ahead.
Okay. Okay. All right. We got it.
No, you're fine. Just stay on task with the due dates. You'll be just.
Well, when I thought I had it when you sent that message, I was like, am I like in some kind of weird nightmare where
No.
I'm and I think I'm not?
The way the course is actually supposed to run, so basically, I've already worked this one too. So sample of 4 ages of students in class, sample variance, sample standard deviation. Okay, so we're looking at sample, right? So here are the ages. to compute your sample variance. To compute your sample variance. Remember, we have to find the mean first. Your mean is, I already have it there. The mean is the sum of x divided by n. Okay, and we got 25.5. Let's go to, I know what I was going to do. Let's go to your calculator. Or, let me bring up my calculator. Enter the data into a list. L1, your graphing calculator. Yeah, the app. Do y'all remember how to enter data into a list? Because I've shown you how to do it by hand in the notes. My fingers are not working today. So to get to your list, you're gonna press Stat and Enter. Stat, Enter. STAT and Enter. Okay. You get there? Randall, can you see my calculator? Stat and Enter. All right, so notice I have stuff already in my L1. Okay. To clear this out, you're gonna do second, clear, and enter. That gets rid of that data. What did you do?
I would one bar that and we can like that they need, I mean, operate technically, same population.
Yes. We're gonna enter that. Enter your data. That's what we're going. Your data is 25, 18, 31, and 28, right? You got your data in? We good? No. Do you have a graphing calculator on your phone? Okay. Okay, so the next thing you're gonna do is get out. So second mode to get out. Then we're gonna go Stat, Calculate, one variable statistics. Press Enter here. You have the screen? Okay, it should be L1 already in there. Go down to Calculate. Okay, so on your calculator, which one? Stat crunch. Okay, it's the same function.
Yeah.
Okay. We'll go to that. All right, so notice the first one, X bar, that is your mean. Okay, automatically. The SX, that is the sample standard deviation. Sigma X is the population standard deviation. Where's the variance? The calculator does not give you the variance. So what you have to do is take the sample standard deviation or the population standard deviation and square it to get the variance. So when you compute it by hand, you get your variance first and take the square root. On the calculator, they give you the standard deviation. You have to square it to get the variance. Okay? So that's your point of emphasis or your specialized notes for that. Okay? So if you look in, I repeat, the first one, X bar, is the mean, SX is the sample standard deviation. To get your sample variance, you square it. Sigma X is your population standard deviation. To get your population variance, you square it. You raise it to the second power. Got it? All right. So you already have it on your calculator. You saw that the sample standard deviation was 5.568, was it not? If you take that number and square it, it's going to give you that 31. Okay. What does that mean? It says the typical difference between the ages in this particular class is 5.568, while the average age is 25.5. Questions on that, please? I'll leave that up there for a minute. All right, we're almost there. Coefficient of variation is next. Coefficient of variation describes the standard deviation as a percent of the mean. Coefficient variation describes the standard deviation as a percent of the mean. And it makes sense. Remember, sigma is your population standard deviation divided by your population mean. Multiply that by 100 and gives you a percent. Likewise with the sample, coefficient of variation. Purpose, it allows a comparison of standard deviation when the units are different. It allows comparison when the units are different. You convert them to percent. Okay. Points of emphasis, the larger the percentage, the greater variability, which means the more spread out it is. In the first example, it says the mean number of sales mean number of sales of cars over a 3-month period is 87. The standard deviation is 5. The commissions are 52.25. Standard deviation 773. Compare the variation of the two. In other words, they want you to compute the CV for sales and a CV for commissions. These are two different units. Coefficient of variation allows us to compare. Okay. So what are we looking at for sales? It's the standard deviation. What's the standard deviation for sales? 5 over, okay. 5.75. Remember that's percent. Commission. $14.79%. Which one is the largest? So that means that what does that mean? You need to get the top there. 14.79%. How does that compare? What does that actually mean as far as stability?
So,
The larger percentage is more spread out, so it's not as consistent. Okay, it's not as consistent. When you think about car salesmen, right? In commissions, the commissions vary. Very big time. Based on who you know, right? Right, so that just simply means that there's more variability among the commissions, meaning that they're not as consistent, they're not as tight as the sales. Okay, question, can you put those lists in for me? And compute the coefficient of variation. So we're looking at a sample of SAT scores for 8 males and 8 females. I can't switch the screen. That's what I'm doing with that. I hope we'll all arrive at the same answer.
I did two separate lists.
That's fine, okay? So you entered the males in L1 and then the females in L2. That's fine. If you do that. If you do that, you're going to do stat, calculate, and do a 2 variable. Stat, because you got 2 in there, 2 variable stats. X list L1, Y list L2. So it's going to run them independently. And after this one, I'm going to go to the homework and see where we are with it. You'll all arrive at the same answer. Hopefully I didn't jump. 1520, 1750, 120. 1710. Second mode, read it out. Then you're going to do a stat. Calculate this function. Needs to become your friend. Everything, you can find everything under this one. Okay. Stat, calculate one variable. Okay, so you got L1 and L2. We're good here. And then press enter to calculate. Do we have the same numbers? Fingers crossed. Okay. So what do we need for coefficient of variation for males? What is the, we're looking at sample. So what is the sample standard deviation? Okay. The 341.67 divided by the mean for the males is 1642.5. I'm going to multiply that times 100%, and that's going to give you 20.880. Okay. Okay. Go to the males. So on the males, if you just scroll down and look at your wives, that's your second data set. So CV for your males, females, I'm sorry. What are we looking for? Sample standard deviation. The mean. Okay, 1710. Multiply that by 100%. 17.69 confirmed. Okay. Yes, no? Yes.
Yeah.
You sure? Okay. Which one is what can you say about these? For the males, we got 20.8. For the females, we got 17.69. The males are more spread out. Yes, because your percentage is larger. So there's more variability among the males than females. That's what that means. All right, so let's go to questions. Let's take a look at the homework so I can see where we are. I hadn't gotten to the Z-score in the notes, so when we get to,
That's what
it's the Z-score, that's the easiest thing. That's the easiest thing. I'm gonna sign in real quick. I know we're supposed to take the money. I know. So this is that. Hopefully it doesn't move me out. So what homework are we working in? Okay, let's take a look at 7. Okay. This one has 16, 17?
Yeah, it's like it's not matter.
Oh, gotcha. Okay. Question 8. Okay, so this one is, oh, okay. Oh, right here. Does it have stack crunch here? Okay. Let's see if I have right to stack crunch. Okay. Okay, open the stack crunch. Like I said, disclaimer, I'm not a stack crunch or Excel user, so we want, uh-oh. Oh, really?
Yeah, I got it. I feel like that. I think we do that.
Okay. You just like the data entry by hand. That's good. At least it gives you access. Okay, so my entries are what, 7? Try to put 7? No. I'm not gonna do that. Oh, let me type in. What's happening? It's not letting me type anything in. You said they let you type in on yours?
Yeah.
Okay. I don't know. You sign in with your,
I just walked in.
and it opened up. We're gonna see if that does it. Nope. Oh, Stack Crunch is not working on my end. How did you get it to work on yours? Okay, y'all test that out and see what you come up with. Uh-huh. Everything you need. So probably that's why I've been using my calculator. Because I don't know if it's something, I don't know. What else can we do? It says open in Excel. So my Excel users. Okay. Okay, so it's in there. Let's look at more functions, maybe statistical. That's covariance sample. Oh, yeah. Okay. I'm gonna have to stick with what I know. Just because that's what I know. Cause this budget doesn't use that. Nope.
So, I will pick her.
Um, so this one asks you to compute the mean, median, and mode. We could do that, right? The range, what is the range? Max minus min? Okay, and then your standard deviation and coefficient of variation, we've done that. Z-scores. All right, how do you compute the Z-scores? Your Z-score is computed as your X value minus the mean divided by the standard deviation. Okay? Your Z-score is the X value minus the mean divided by the standard deviation. This data set is small. Go ahead and enter those data values into your calculator in L1. What are they? 7, 2, 8, 9, and 6.
So the X value is N equals 5?
The X value is 7. The X value is 2. So we have to do it for each one of them. That's why it's 13 parts. Okay, so first step, enter your data into a list. In L1, the data entry 7, 2, 8, 9, and 6. And run a one variable statistic. Eight, 9, and 6. Second mode gets you out of the edit menu. So then you're gonna go stat, calculate, one variable. And press enter. We get the same thing. We got X bar. What is sample standard deviation?
3.7.
Okay, so we got the mean. Now, here's the trick. If you scroll down, what do you see? What's the median? MED? 7. So it gives us the median. You have your max and your min. So we could do the range. Your range is 9 minus 2, which is 7. Is that all we need? Variance. Variance. How do we find the variance? Square. What are we squaring?
The value of the circle.
Sx, so 2.70 squared. That's going to give you what? I'm writing them down so I can input.
It's equal to 0.
7.2. Okay. All right, now, we got that written down. Your z-score, you're gonna take your first x value, which is 7, take your first x value. Oops. Z-score, first x value, which is 7, minus the mean, which is 6.4, divided by the standard deviation of 2.70. The x value, x minus mean,
I thought our standard deviation was something.
that is the variance.
Variance, okay.
Okay, so now the question is, how are you entering that in? And then divide by 2.7? Okay, 0.222? Okay. Let's see if that's an issue.
That's what I tried to do.
Okay, so now we gotta enter all of that stuff to get to that point. Let's check our answers.
If I get it wrong, I'm just gonna do it. Because I did have double bid. So I don't know if I did it right. That's my places.
Yeah. Okay, so what did we get our mean to be? What was our mean? 6.4, and was it flat 6.4? Is this type of integer or decimal? Do not round. Uh-oh. Did we round? Let's see. Nope. Okay, it's 6.4. Okay. Because if you're off by one decimal, it's going to count it wrong. 6.4. Got that one. Okay. Next one. What was the median? Our median was what? 7? Okay. Next one. Mode, we didn't, okay, there is no mode because nothing is repeated, correct? Okay. Enter. What's next? The range. Which was 7, okay. Next, the variance. Variance, it says round 2 decimal places. Variance. Round 2 decimal places. Preferring 2.70?
I thought that was
That's where
standard.
it's square it.
Okay.
It's like 70 something.
2.70 squared gives you what? 7.29?
Yeah.
Confirm? Oh, come on. Okay. Standard deviation says around 2 decimal places. 2.70? Or did we round? We're gonna find out. Okay, good. Coefficient of variation, we didn't compute that. Coefficient of variation, how do you do that? So what is it? Standard deviation divided by your mean. Standard deviation divided by your mean. And then multiply that by 100. And we want 2 decimal places. Standard deviation was 2.70. The mean was 6.4. 42.19 confirmed. Mm-hmm. 42.19. I'll wait because I don't like seeing the red X up there. $42.19. We only have 7 more parts on this one problem.
There's one of like 13 or 17.
You were supposed to report that by 100.
By 100.
I got 17. I don't know what I did.
It's 2.7 divided by 6.4.
I don't know.
Yes. Yeah. Everyone will have a different problem.
If you round up in 40,
42.19. Okay. Good. Okay. Here we go. Z-score. It says round 2 decimal places. What did we get for the first Z-score? 0.22. Okay. Okay. What happened? Next one. 2 minus 6.4. And you're going to divide that by 2.70.
negative 1.63.
Okay. Confirm. Negative. Not in the box. Nope, still not in the box. Negative 1.63. There you go. That's it. That's why I was wondering how you keyed it in. Because if you put it all together, you have to have that numerator in parentheses.
I did that on my homework.
Okay. So we got the Z-scores now? Okay. Let's go ahead and finish this up since there are only a couple more so we could get to the shape of the data set. Mm-hmm.
First and third quarters, we have to do 500.
Not yet.
Translate.
That's later on. This is where it's going to be skewed left, skewed right. Mm-hmm.
45 minutes.
What? How much?
45 minutes.
Okay. 0.59. Okay. Mm-hmm. Next one. Okay. Next one. This one number probably takes care of everything. Negative 0.15. You got 19? Oh, okay. All right. Are there any outliers? No. I won't say no. I want you to say yes, it is. It's 2. But it's not really. All right. Describe the shape of the data set. All right. Okay. So let's go back to this screen on the shape. Okay, so it's symmetric when they're all equal. It's symmetric when the mean, median, and mode are all equal. It's symmetric when mean, median, and mode are all equal.
So with the first example that we had when we started class, right at first when it was like 7.2, it was nearly all equal, would that still be considered symmetric, or is that like decimal?
That decimal threw it off, 7.31.
So it's not like close enough, it has to be exactly.
Yeah, that was the.
That one was interesting, because I mean, it was hard to
Mm-hmm. The mean is, no, the mean and
I thought the
and
mean was, I thought the mean
Yeah.
was higher than the median.
the mean was higher than
So
the
it was
mean.
interesting.
Okay. Uniform. They all have the same frequency. Skewed left. Skewed left. The mean is less than the median. Okay. The mean is less than the median. So your median is always in the middle. Skewed left. The mean will be smaller. Ooh, I can't write. How about MEAD? The mean will be on the left, smaller than the median, and then the mode will be over here. Skewed right. Skewed right, you'll have mode, your median, and then your mean. If your mean is greater than your median, then it is skewed right. So going back to our problem, our median was what? Our median, I think, was 7.
Yes.
7. My mean was 6.4. So where is the position? Is it smaller? It's to the left, so it is. It is skewed left. Your mean is always going to follow the tail. The mean is always going to follow the tail. So what does that mean pictorially? Skewed left. Here's your line, and this is an exaggerated graph. You have the hump on the right, and it tails to the left. Skewed right. Did I put that in the, oh, that's skewed left. Skewed right. It's exaggerated. I still did that backwards. And let me try it again. It's on the opposite side. Skewed left. No, it wasn't. Skewed left. The hump is on the right. Okay, like so. And skewed right. Tails to the right. Let's tail to the left. As far as your picture. So the mean is going to follow the tail. The mean is going to follow the tail. So we did z-scores. We did the coefficient of variation. We did the shape and distribution. Let's see. Let's enter the answers for those. What did we say it was? Skewed left. Oh, we only did one final check. All right. So you have a couple of those. That's question 2, same thing. Nothing different. What was that? I don't remember. I don't know. Don't have an example of that one. So let me see what we want here. I forgot about this one. The geometric mean is the mean rate of return. Okay. Okay, so the first one on the past 2 years. So the computation, it looks like it is 1 plus R1, where R1 on the first one represents 20%, and R2 is 55%. And then you're subtracting 1, raised to the 1 over n. Let me write that down. It's only been a year since I've looked at it. Geometric mean. So I can add it to my notes for next time. It is 1 plus R1 plus, times 1 plus R2 times 1 plus R sub n. All of it is raised to the 1 over n power minus 1. And then I think the rest of it is the simplification.
Okay.
And
So
express it.
why, as soon as it comes down to setting up the equation, does the ellipse x1 plus r sub n go away?
N is the number of entries that we have. We only had 2. Okay, so it's saying right here, it's going to continue in that fashion until you reach all of your data entries.
Okay.
Okay,
Okay.
so in our case, the N is a 2. In our case, the N is a 2. Okay, so going back to our problem, what are we given? 10% and 35%? Are those the only 2 values? So my R1 is 10%, that's 0.10, and R2 is 35%, 0.35. So your geometric mean will be 1 plus 0.10 times 1 plus 0.35 raised to the 1 over how many entries did we have? 2. And then we're going to subtract 1. Be very careful. Let's make sure we all get to the same. That 1/2, that fractional 1/2, is nothing more than the square root. Yo, looking at each other like, you got a nigga?
Right. deducting it in the ranks first, and then raise that to the power on that, and that's all. So you can, just get 1.1.
This, you get something different? Times 1 point. Mhm. And then you raise it to the 1/2. I'm still positive there. When you raise it to the 1/2, make sure you enclose the 1/2 in parentheses.
That's what it's on.
Okay. So what we get?
I just took the square root there,
Okay.
and I wasn't going to round up until the very last one.
Okay.
I got 0.218.
Okay. So we got 1.2186 minus 1, which is gonna give me 0.2186. Okay. Then we want it as a percent. So that's
Are we rounding up?
multiply by 100.
Okay.
21.9. One decimal place. The geometric rate of return. We were saying 21.9. The percent is already there. Mean, median, mode. All right, okay, that's the same thing. Coefficient of variation. Mean, median, and mode. I believe everything is the same there. That's the one that has 14 pieces. I think we've already done all of those. We've done all of those. Coefficient of variation, we've done that. And we've done that. All right, so that was homework 7. What is homework 8 look like? I think that was the longest one. All right, yeah, we'll go ahead and take a quick break. Fingers crossed that everything is gonna stay. Worst case scenario, I won't be able to do it, it won't record. But I could still project my notes and stuff.